Hello, everyone, and welcome again, since you probably couldn't hear anything that I was just saying. I'm happy to be here this afternoon, and good morning, good afternoon, good evening to you all, wherever you're tuning in from today. My name is Meaghan Lewis, and I am a program manager on the Reactors team. You might have caught me before on previous streams, and today and this week, actually, we're doing a series of Rust streams. So I am happy to be here to have kind of a fireside chat this afternoon about the Rust programming language. I will be joined momentarily with my co-host today, Principal Software Engineer Arlie Davis. And what we're going to do over the next hour or so is just to kind of talk about Rust, talk about the benefits of using Rust, why you would use it, how to get started, how we're using it in Microsoft internally, and that's about it. And hopefully can get to hear from all of you. Ask as many questions as you like. We'd love to hear from you, just kind of what brought you here today, what your experience with Rust is. And yeah, that will be a little bit of it, but it's going to be very casual. Excuse me. So let's go ahead and get started, and I will introduce my co-host now, Arlie Davis. Arlie, welcome, and thank you for being here. How are you doing?
Hi, doing great. It's good to be here. I'm always.
Oh, you're super quiet again.
Oh no.
Uh-oh.
Hello.
It's probably not just me, right?
Can anyone hear me at all?
It's super quiet. We can hear you.
Should I try re-entering the app again?
Yeah, can you try that again? Okay, technical difficulties, folks. We will try this again and be back shortly. All right, so while we're figuring these problems out, yeah, I'd love to hear from y'all in the chat, kind of what brought you here, how long have you been using Rust, have you used Rust at all? And feel free to start queuing some questions up, but we will get started in just a moment.
Hello.
And
Any
you
better?
are back and sounding great, so let's do it.
Maybe the trick is to just keep talking the whole time.
I don't know. I'm not sure really what the trick is sometimes, but I think we're all good to go now. So welcome again, Arlie. Thanks for being. You want to just start with an introduction? Tell us a little bit about yourself, your journey with Rust so far.
Certainly. I've been at Microsoft for, hard to believe, almost 20 years now, and a good deal of that time has been spent focusing on safer systems programming languages. So that's languages where they're in this intersection between languages that are safe by a certain definition, where you can't create certain errors like buffer overruns, and languages which are acceptable for use in systems programming in very low level or very high performance situations. And so a lot of the work that I've done has really never seen the light of day outside of the company. I'm really excited that the industry has shifted toward Rust these days because it allows me to talk about what is possibly my favorite subject now. Awesome. I spend my time now at Microsoft focusing on enabling groups that are potentially going to use Rust within Microsoft to use it correctly and to use it in ways that conform with Microsoft's requirements, and also just contributing to Rust generally.
Sounds great. So it sounds like you have quite the level of experience with Rust. So yeah, definitely happy to kind of just talk about, what are the benefits of getting Rust? And I guess let's just go ahead and start there. Let's just jump right in. And that was the first question I had. So yeah, what are the benefits of using Rust that you would say?
The benefits of using Rust. So Rust has been described as a language that's not a new language, but a kind of a repackaging of old and powerful ideas in a way that's more accessible to more people now. So there's really two things that come together to make Rust attractive or powerful. The first is, as we mentioned, it's safe. It has a certain definition of safety. A lot of developers these days have just sort of grown up with safe languages and aren't really aware of this distinction in languages. And what I mean by that is languages such as almost all scripting languages and a handful of compiled languages such as Java and C# and many others, but maybe languages that people are not quite familiar with, are safe by a certain definition. What I mean by that is the language defines and verifies that you are correctly using memory or correctly using other parts of the language. So for example, if you're writing a program in Rust or Java or many other statically typed safe languages, if you're writing a program in Rust, if you write a bug, like trying to access an element out of an array or outside of a buffer, your program will deterministically crash. The language will detect this and it will terminate your process. We contrast that with languages like C++ or C, where, and this has been a huge problem for the industry, if you write a bug such that you read memory or write memory outside of the bounds of an array, the results are highly dependent on just what that machine was doing. You may cause a security bug. You might crash your program, but it may be non-deterministic. In any case, it's been an enormous source of frustration and lost money and slipped schedules to be working in these languages that are unsafe. So safe languages are a huge topic that you can find out a lot more information about elsewhere. What makes Rust so powerful is that it's the intersection between safe languages and systems programming. Now, systems programming means different things to different people, but the main definition that I work with is what I can ship on Windows and have other people build programs on top of. So that's almost every layer of the operating system stack, everything from potentially in the future, we're not doing this right now, but we're actively investigating it, implementing things in kernel mode like device drivers, or implementing low-level things like performance monitoring and heap implementations and event systems and graphics and everything in the entire operating system stack with efficiency and performance that is competitive with the languages that we've used traditionally. And that's mainly been C and C++. So Rust is enabling those two use cases of safe languages and systems programming to finally come together in a way that has really not been possible or practical in most environments until now. And that's what's got me so excited. And so because of that, and we'll talk about that a little more, I'm sure, it's also bringing different approaches or different communities of developers together. So developers who have traditionally relied on safe languages, and even though they might not have been aware that they were doing so, like JavaScript and most of your scripting languages and such, are now able to bring what they've been doing into niches and areas where they've really not been able to use those languages before. So although you could stand on your head and maybe do it, it wouldn't be a good idea to write a device driver in JavaScript. But it's entirely practical to write certain kinds of device drivers in Rust, or to do embedded development on IoT devices in Rust. And so that's a kind of example of something that was not really practical 10 years ago.
You're still talking, but I did lose your audio again, Arlie.
Okay, entirely quiet again?
No, sorry, maybe you're fine now. That was just my bad. So we did get a question. I just was hoping that you could expand a little bit on what do you mean by safe language? Can you give us like some examples of what that means?
Certainly. So it's an interesting topic that there's a little bit of disagreement on what safe means. It doesn't mean free of bugs. It means that the language defines how you can do certain things, like how you can store data in memory, and the language protects you from violating that definition. So, for example, in C, if you allocate a buffer of memory, you call the malloc function to allocate a buffer, and you tell malloc what size of that buffer should be. You're on sort of Scout's honor to use that buffer correctly. You're on Scout's honor to only access data within that buffer, and you can accidentally access data outside of that buffer. And you're on Scout's honor to not use that buffer once you've called the free function, once you've destroyed that memory. And there's just thousands upon thousands of examples where developers who were trying really hard were not able to conform to those rules in non-trivial systems. Now, in a language like Rust or C# or Java or many others, the language defines the requirement, the invariant, that you cannot access memory outside of that buffer. And so any attempt to do so will either be detected at compile time in some ways, in some very restricted cases, or at runtime. And so you'll get either an array bounds check violation or some other deterministic way to report that your program didn't behave the way you thought it was supposed to. So again, the really crucial distinction is not that static type systems or safe languages exclude bugs, but they contain the damage. And in many cases, they transform a non-deterministic problem, like sometimes my program crashes, into a deterministic problem of my program always halts at this point because the system detected the violation of its requirements. And in many other cases also, and Rust is almost uniquely powerful here, the compiler can do certain checks at compile time rather than when you run the code. So for example, a use after free bug in C is a case where you've allocated a buffer, you've used it, and then you've freed it, and then you've used it again, and this violates C's requirements. In Rust, that bug is basically impossible to create. The compiler detects when a piece of memory has been freed, and you simply cannot access it after that point. The language at compile time is smart enough and strict enough to detect that for you.
Awesome. Okay, great example. I think that that definitely clears up how Rust is a safe language. So next, let's maybe talk about why would you choose Rust or not choose Rust for a project?
Well, I'm a little biased. I choose Rust to begin with for almost everything, and then I look for reasons why I can't.
Okay, we did lose your audio a little bit. I don't know what's happening here. If you just got so quiet, it just sounds like almost like the mic is just getting cut down.
I swear I'm not the one talking quietly.
Oh, and you're back just like that. Okay, well, here we are again, folks.
Okay, so when to choose Rust and when not to. On its merits alone, there's almost no reason not to use Rust now. Rust as a language is very mature. It has a very mature ecosystem of packages that do almost anything you would want to now. Access to websites, access to databases, all your usual web backend stuff, machine learning, all sorts of things. I'm not saying every single package is at its absolute best, but the ecosystem is really there. So the reasons to not use Rust are mainly where you already have a large, complex software system, and it's difficult to find how to kind of slot Rust into that system. So we call that the kind of the integration problem, or the FFI problem, the foreign function integration problem. If the way that you need to integrate a component is by directly compiling one component against another, like if you have a C++ library and you want to convert one part of it to Rust, that's really the hardest situation because the two languages really don't have the same view of the world. If your integration point is something like a web API or a REST API or a data storage format on a server, then you're actually in really good shape because there's no incompatibility in the view of the world. It's just data. It's just web requests, or it's just structured storage. So if you're working with JSON, or you're working with XML, or SQL databases, whatever, any language that can access those has the same view of the world. And so Rust is on equal footing there. So there's way more detail to it than that. And frankly, that's what I spend a lot of my time with in working with groups is on a really detailed level, where can they or where should they use Rust, and where should they either defer it or not use it at all? And the answer is generally, if you have to integrate with a lot of C++, then really think deeply about whether this is the right decision, at least at this point in time. And for almost everything else, I think the answer tends toward yes, Rust is probably a good fit for what you want to do.
Awesome. Okay. Yeah, that's helpful. I think all of that was helpful. Like the way that you kind of summed it up at the end sounds more straightforward. And I guess I'm thinking now, and I'm seeing a couple questions come into chat. It sounds like we have a couple students here in particular. So a question that came up was, okay, I'm a graduating computer science student. Would learning Rust benefit from would Rust benefit me on my resume from applying to Microsoft? So I don't think we have to, and I don't think we can advise you, whoever asked that, Frank Savage 7, I don't think we can necessarily advise you on what's best to put on your resume, but I would like to maybe talk about, like, would you recommend Rust as a language to learn for students? I'm also asking this because someone was saying, I'm just kind of starting out learning programming, I'm familiar with Python, and I think that's, what is probably more common especially if you're just learning programming. You might learn Python. I know that when I first learned, I learned Java, I learned C#. So like Rust is probably one of those languages that you would not learn in school, but is that something that you would recommend as kind of maybe a first programming language or someone who's new to getting started programming?
I would strongly recommend learning Rust, not necessarily because you're going to walk into a position where using Rust is the first thing you'll do, but because it will teach you deeply certain really important concepts. Every developer that I've worked with that has done a substantial amount of Rust work now says that what they've learned in Rust has always transferred to other domains, to other languages, especially to C++. So it's really the deep ideas in Rust that are attractive and valuable, and sort of the mindset that Rust cultivates. And what I mean about that is Rust has this unique way of analyzing languages called the borrow checker. And the borrow checker verifies that you're using memory correctly in certain ways, and especially in the lifetime of memory. So learning these concepts are highly transferable. And other languages have these concepts, like C++ has a lifetime model, but what C++ does not have is a compiler that can verify that your code meets that model. And so if you spend the time to learn Rust, and even just learn to write basic or intermediate programs, you'll find that you learn so much that transfers elsewhere that you will have gotten back the time you invested in that many times over. I can't speak at all to which groups are looking for Rust candidates. We really don't hire based on a specific language or a specific technology. We hire for general capacity, and I always look for willingness to learn. So, developers who come in the front door who are willing to learn Rust or willing to learn whatever crazy thing comes down the pipe next are the people that I really look forward to working with.
Okay. Awesome. Yeah, I think that was very helpful. And Frank Savage, I hope you also found that helpful. Yeah, I don't think we can necessarily tell you what looks great on your resume, but like Arlie said, as long as you have kind of that willingness to learn, and probably some background with some programming language will help, but I don't think you need Rust in particular. So there was a question earlier around what domains Rust is being used in heavily. I've heard it being used in WebAssembly, but where else would it be used? So I don't know if by domains, if this is like maybe talking about use cases or any other kind of like corporations that are using it. But maybe it's kind of a good time to switch gears and maybe even talk about, like Arlie, how your team is using Rust at Microsoft.
So the domains that I've seen the biggest adoption of Rust and the biggest sort of wholehearted adoption of Rust, there's a number of good white papers on the Rust language website itself. And I think the Dropbox paper is maybe one of the most interesting ones to read about. Are those domains where people have had really high requirements for security or web service uptime, and they can't afford to keep nursing along components that are failing at some percentage that is unacceptable, either in resource costs or in reliability. And they finally taken the time to rewrite a component in Rust and gotten substantial gains in reliability and in greatly increasing the efficiency of their resource utilization. So, for example, there was one service that rewrote one of their log analysis components. I forget which source language they were using, but they saw something like a 20x improvement in memory utilization and a night and day improvement in the reliability of their service. And so the services that seem to really benefit the most from Rust are those that already have an established pipeline of some kind. They have components in production, and they understand that they have weaknesses in those components that they have not been able to address. That, especially in the work that I do, C++, it's very difficult to take a large, mature C++ component and make it substantially more reliable. It's a really hard problem in this domain. On the other end of the spectrum, it's really hard to take components that were written in a lot of web scripting languages, like Node.js and such, and to make them far more efficient. These components tend to be reliable because they're implemented in a safe language, but they can't get anywhere close to the efficiency of C++ or Rust. And so a number of the white papers are instances of that pattern, where a company has converted an asset from Node.js to Rust and seen tremendous gains in their efficiency. And being able to scale the number of machines they have to deploy way down and still have an improvement in their overall throughput. So that's a lot of the cases that I'm aware of externally. I can't talk about specifics of the groups that I'm working with internally, but those tend to be of a slightly different flavor. Those tend to be services and not so much user-facing components yet. That's what that's what I'm working on. Organizationally is finding where it's a good fit and where it's not a good fit. And I think there's tremendous value there. But the reality is that domain has been sort of C++, it's turf for decades, like the client, we call it, right? Your Windows desktop, your user-facing applications that are compiled in C++ and shipped to users. And also, frankly, the center of gravity has shifted away from that environment and much more toward web and mobile.
Mm-hmm. Awesome. Thank you. So let's keep going, and I'm going to slightly switch gears again. But the next question I have for you is just, has Rust brought together different communities of developers? And are there any examples of where you've seen that happen?
Definitely. To the point that I think there's a revolution happening, and I know that sounds kind of like exaggerated speech, but I think it's a slow motion revolution where in the 80s and 90s and early 2000s, really the center of gravity of the industry was C and C++ and was software that we compiled in those languages and shipped to customers. We shipped it on a CD, or someone downloaded an executable or a tarball or an MSI file and installed it on their machines. And that's just not what people do now. That's not how people get most code now. Most code comes to people over mobile apps, and almost all of those are in safe languages of one form or another. The core of those apps is often not. Like if you download a mobile game, the core of it is often implemented in C++, but a lot of the UI-centric things that control the experience are in Java on Android or in Objective-C on iOS. So the center of gravity has really shifted away from the old pipeline of building C++ code and shipping it to users to mobile code, both in the sense of mobile devices and also in the sense of code that is transferred from web servers to web clients and browsers in JavaScript. So those two worlds evolved quite separately. And for a long time, I think some people viewed them as antagonistic, as mutually antagonistic worlds. You had your old guard and your new web guard, and the new web technologies really evolved completely outside of the domain of the C++ developers. I think Rust is interesting because it is kind of bringing those two back together. A lot of web developers are interested in Rust because they see it as a way to get nearly all of the benefits of the languages they are using from the web technologies, and finally recapture that last bit of performance, recapture that last bit of efficiency or power, or being able to run in extremely resource-constrained devices like IoT devices. So people who grew up with Node.js look at the Node.js ecosystem of the language plus the package registry, and then they look at Rust and its package registry, Cargo, and they go, oh, it's really just a shift from this syntax to that syntax, and then I learn about the borrow checker, and then I'm ready to rock. So a lot of people are able to come from the web technologies domain into the systems programming domain through Rust. There's some movement in the opposite direction of people who have traditionally been kind of self-identifying as systems programmers, now seeing that Rust allows them to preserve a lot of the value that they get from their languages and yet push into new domains. And WebAssembly, or WASM, is maybe one of the better examples of that, where Rust allows you to write fairly efficient systems programming code and yet run it within a safe sandbox on browsers. Does that at all address the question?
I think that addresses the question. And what you're saying is that, I mean, essentially, Rust is for everyone. Like, I think what you're explaining is that Rust has done a really great job of bringing together system programmers and web programmers together.
I think yes, with a giant asterisk. There are some unsolved issues and questions around Rust, and they mainly come back to how to integrate Rust into certain environments, like integrating into a large C++ code base. Those are hard problems, and some really great people are working on them. There's all sorts of stuff you can find out there on Rust and C++ integration. It's a hard problem. In some ways, I think it is an over-constrained and therefore, in the general case, unsolvable problem. But we're going to keep chipping away at that.
Gotcha. Okay. And so that makes me think of another question. So, like, as we're talking about these communities, that Rust has been able to bring together, and trying to solve complicated problems like you just mentioned. So what are the best ways that Rust developers can kind of get that support when they're trying to solve really complicated problems? And on the same lines of communities, are there communities that are best to kind of work with to help answer some of these questions and solve problems, whether maybe internally at Microsoft or externally, that you've found helpful?
I think Rust has been almost a model example of how to run an open source community from the start. The Rust language committee, or whatever they call themselves, I'm sorry, I don't have the exact name in mind, have done a really excellent job of keeping the development and design and future plans for Rust very open. And in all of the work that we do inside Microsoft, we want that to continue. We want to just participate in that process. There's no reason for us to duplicate that effort internally. Mm-hmm. So Rust very early on made some excellent choices in how to manage growth and how to prepare the language and in some ways the community for evolving Rust without disrupting people who had made early investments in Rust. So the way the language itself works is there are strong compatibility guarantees built into it. If you write a Rust program against version 1.21 of the compiler and you download version 1.25 of the compiler, it's guaranteed to still compile your code and work. And that's a stronger guarantee than is present in a lot of other languages. A lot of other languages sort of pride themselves on one of two extremes, either extreme compatibility where the language evolves very slowly, or extreme agility where the language evolves so quickly that you're just going to be lost if you don't update your code every month with that. So the compiler has specific ways to mark the version of code. So it's not just a Scout's honor promise from the developers. The compiler knows how to identify this language element, like this type or this function, was introduced in Rust version 1.42. Mm-hmm. And so when scanning through the code, you can know what to rely on in particular versions of the compiler. And the unit tests and integration tests for the Rust language really do verify these things. So that's been a great way that the Rust community has really set itself up for both growth and stability at the same time.
Right. Yeah, makes a lot of sense. Thank you for answering that. So let me switch over and look for a chat question now. So one of the recent questions that came in is, currently apps like Teams are distributed as an Electron app. Is this going to change into a native app written in Rust? I'm just going to ask the question, but I don't think that there are any plans for that, and I don't think that we would be talking about this. But I'll pass it over to you, Arlie, if you have any other thoughts.
So interestingly enough, I think user interface development is one of the areas where Rust right now is weakest, and there's a couple of reasons for that. A lot of the strengths of Rust accrue to its lifetime checker, its borrow checker, and the way that you write code with that borrow checker is sort of, it's like oil and water with the traditional way that you write user interface code. So with Rust pushes you very strongly to a direction where you don't have what's called aliasing. You don't have lots of pointers where one object points to another object, points to another object. Rust really wants you to minimize those pointers so that it can verify that your program uses them correctly. In most GUI development, there's pointers everywhere, just all over the place. And that's true for old school C++ GUI apps. That's true for new school JS apps and React apps, and apps internally like VS Code and Teams and such. They're all built in that style. And so whether or when Rust will be a good fit there, that's one area where I wouldn't hold my breath. And where even if Rust was a good fit, I don't see that much benefit from it. JS and other languages are doing a fairly decent job of that already. I live and breathe in VS Code all day long, and I'm actually pretty impressed with how responsive it is. And I'm impressed with knowing just how much of VS Code relies on scripting languages, on JIT compiled JS, and achieves really respectable performance. Memory utilization is a little higher than I would like it to be, and maybe that's an area where Rust could bring some benefits, where the stricter type checking could help you reduce utilization there. But the solution for that has mainly been just throw memory at it.
Gotcha. And so you did mention Rust not being a great option for front-end programming, but I'm wondering if like there are any particular front-end frameworks that you've found useful, or maybe if you haven't personally found them useful that you've heard about for kind of that front-end GUI programming with Rust.
Unfortunately, that's an area where I really don't have a ready list of answers for you. I've periodically checked in to see what's the state of the art with GUI development in Rust, and there's a number of interesting projects out there. They really fall into two groups. In one group, you have people trying to use Rust to bring existing frameworks and approaches to Rust, like GNOME or XAML or other things like that. And I know that the WinRT project is one of those where Kenny Kerr's WinRT project has been able to take WinRT metadata and project that into Rust classes and fairly quickly light up a great deal of UI code. Those tend to be very platform specific. If you're lighting up WinRT, well, that's really only going to work on platforms where there's WinRT, and that's only Windows right now. The other group tends to be those where someone wants to build a whole new UI framework, and they want to build it in Rust for Rust. And those are much more experimental and much more ambitious. They tend to be more hobby projects than anything that is intended to ship to users. They're really, as much as I adore them, and I've actually, I have one of those of my own on the side that it will never see the light of day. As much as I adore those, they're not going to catch up with large, mature, powerful, rich frameworks like Electron.
Gotcha.
Where I really see a good combination of those two environments is things like 3D games. I think a good deal of the core of a 3D game engine would benefit tremendously from Rust, mainly in it's going to be efficient and it's going to be reliable, and that really matters for AAA titles. Like, there's so many games that have been shipped hastily to the market to meet the Christmas demand for games, and they're terrible from a reliability point of view. They crash left and right, and they're always patched in February or March. And so there's just a reputation for that, the reliability dip that occurs near Christmas. Mm-hmm. Rust could help with that problem tremendously. A 3D engine written in Rust with most of its upper layers of game logic, like weapons models and quests and all that stuff, written in a more agile language like JS, that would be a really powerful combination. And that's where I know there's substantial investment already. There's a good deal of 3D gaming investment in Rust game engines right now.
Right.
I don't know much more detail than that, but it's out there if you want to dig into it.
Okay, good to know. Yeah, I've heard about the same and know nothing else, but that's something that I've wanted to kind of check out in particular is Rust gaming engines. So I think something about what you were just saying is really closely aligning to some of the questions that we got in recently. So the first is, what are some of the side projects that you're working on? Or maybe tell us one side project that you're working on that you want to talk a little bit about.
I really don't have, I went through and culled a bunch of my side projects because I realized they were learning exercises and they really weren't that valuable, and it was more trouble to keep them going than to kill them. So I killed most of my side projects. I mean, I have a few crates out there. I thought one of the more interesting ones was I ported Berkeley Yak, which is a compiler framework, a very ancient, not very great compiler framework, to Rust. And that alone is not that interesting. But the interesting part was Rust has what are called procedural macros, where you can essentially write extensions to the language. You can write plugins that run in the compiler at compile time, and they take as input Rust code that you write, and then they do whatever you want. You write Rust code that transforms Rust code into yet more Rust code. It's like a very, very infinitely powerful, it's a Turing complete preprocessor. So I used that in my port of Yak, which I called RAC. Yak stands for yet another compiler. and rack stands for Rust Another Compiler.
Got it.
So in rack, I use procedural macros to allow you to write a grammar in Rust that is analyzed and then its final form is emitted into your Rust program. And so you can very easily write your grammar along with the actions that your grammar takes when it's parsing in a single file. And when you're using traditional Berkeley YAC or a lot of other traditional language toolkit frameworks like this, what you do is you write your language definition in one file, which is this very weird domain-specific language, and then you write your code in a different file. So your YAC file and then your C++ file, and then through the magic of build systems, it's combined into one thing. And so I did rack as an exercise of uniting those into one language. So you write code that is mostly just Rust with a couple of cute little annotations, and then your grammar spec in Rust. So that's one of my side projects. Don't go look it up. It's a terrible
Don't go look
exercise
for that.
I did
Gotcha. Well, I mean, it sounds like it was a good learning exercise and pretty useful. Let's see. So there was also a question from Moleman Coyote about when was the first time Rust really wowed you?
Well, I guess I have a strange pathway here because I was working on language projects that were quite similar to Rust before Rust was released. I was working on a language project inside Microsoft on a project called Midori. And our goal was safe systems programming languages, the exact same goal as Rust. We started from a different place and we ended in a different place. But the main thing that differentiated what we were doing from Rust was that we were still using garbage collectors. And Rust does not use a garbage collector for memory management. It's a really fundamental decision whether you base your language's memory map model on garbage collectors or not. We decided yes. In some ways, it was an excellent decision, and in some ways, it was a fatal decision. Garbage collectors can achieve incredible throughput, incredible efficiency, and can be used in really amazing ways. They have a reputation for being slow. It's really unearned in a lot of cases. However, understanding how to correctly use a garbage collector and integrating it into languages that do not use a garbage collector is another oil and water problem. Garbage collectors have a very fundamentally different view of how memory works than malloc and free or RAII in C++. So when I understood, when I first learned about Rust, which was long before even 1.0 of Rust, the borrow checker was the amazing part. And the fact that the borrow checker allowed you to not use GC to achieve equivalent or better performance, that was the wow moment to me, because I already knew what I wanted. I already knew that I wanted a safe systems programming language. I was working on one. The amazing part to me was someone went down the other fork of the road and made it work. And so what we had worked in certain situations, didn't work in other situations. What Rust had worked in many situations, didn't work so great in some situations, but they got to the end, right? They built a coherent system that could really be put into situations that we wanted to be put into. So that was the wow moment to me, was kind of seeing the other side of that experiment and that they achieved success with it.
I see.
Not the perspective that most people come to with Rust usually, right?
That's not necessarily what I expected, but yeah, that's good to know. I think that's a great story. And you've mentioned this a couple times now, the borrow checker and different circumstances. I won't ask you any specific questions about the borrow checker right now. It sounds like that was kind of one of the big features that kind of drew you and wowed you to Rust. But no questions, just a quick announcement that we're going to have another stream tomorrow where Ryan Levick is going to talk about the borrow checker. So if you keep hearing that come up in the stream or in the recording and are wondering about that, we have another session coming up where we'll talk a little bit more about that. Arlie, I won't ask you anymore unless there's anything that you want to say in particular.
Oh, let me just add one thing to that. The borrow checker is really the heart and soul of what makes Rust unique. If you spend some time learning about Rust, focus all your time on the borrow checker. Don't get distracted by the syntax of the language. The syntax looks different. It looks different to some people. It looks really familiar to people who've been spending years working in Haskell or OCaml or things like that. Don't get confused. Don't focus on the syntax at all. Focus on the borrow checker to almost the exclusion of everything else. It is really the most distinctive new thing that has enabled all of Rust's success.
Wow. Great tip. Thank you. So let me switch back over to, I just have one more question or two more questions, and then we'll mainly kind of take questions from the viewers. But this is something that sounds like it comes up fairly often. No one has asked it yet here, but is Microsoft going to fork Rust?
Definitely not. I mean, you can never say never, of course, but I am plugged into all of our internal efforts on Rust. There is no desire or plans to fork Rust. There's no value in forking Rust. First of all, the open source process is simply working. It's producing the language that we want, that we need. The main unmet need that we have that would motivate anything remotely like forking Rust is that Microsoft has a lot of toolchain requirements that are part of Microsoft's history that are not met by the open source version of Rust, and we need to find some way to meet that gap, to meet those needs. Our strategy is to contribute to Rust. We've already made substantial contributions to upstream Rust. You can look up some of the stuff on security on Control Flow Guard, for example. Just to give you an example of the kind of thing I'm talking about, Microsoft for a very long time has had a legal requirement that Windows cannot add new APIs that are undocumented that other Microsoft products can use for very good reasons. So you don't want Windows either intentionally or unintentionally adding a new API that now Office uses to some benefit. You want everyone to have access to that. And so because of that, we have internal tools that mechanically scan Windows to make sure there are no new APIs added that are not publicly documented. Those tools have to work. Those are tools where we are on the line legally for billions of dollars in damages, and that's not an exaggeration, if we get this wrong. And so if we are going to ship components in Windows that are based in Rust, they have to work with those tools. And right now they don't. And so my team is working on how to meet that need. And these are just plans that are evolving right now, so I can't go into details, but everything about the strategy is add to Rust. It's not fork Rust, it's not detract from Rust, it's add to Rust. And we have already done that. Yeah. Ryan Levick has been a big part of that communication publicly, and I look forward to hearing what he has to say too.
Fantastic. Good to know that we are not planning on forking Rust, only continuing to contribute to this great project.
Let me add one more thing to that. There's been a lot of confusion around the Project Verona, which is a language project from Microsoft Research. Project Verona explicitly calls out Rust as one of its influences, and there was a lot of confusion when Verona was first publicized. Verona is a research project. It is not a product. It is a research project intended to take the ideas that Rust has demonstrated are viable and see whether we can use that to apply them in certain other domains. I mean, I see this as the most positive possible outcome of Rust's existence, is an existence proof that these are valid ideas. And the job of researchers is to take these valid ideas and apply them to new domains. And so I think there was a lot of unnecessary heat and friction around Verona's release because it wasn't understood that Verona is not a product. It is a project. If there is any result from Verona, it will be to prove that these kind of analyses are more widely applicable than just one new language.
Very cool. Thank you for clarifying that and just for providing more of a background on Project Verona. I don't know if folks have heard about that project. I can drop a quick link into the Twitch chat if you want to learn a little bit more there. But thank you. So let's see. I think let's go ahead and I'm going to switch over to the chat and see what's come up here. Okay. So one question that came up from DediQ was, how does Rust deal with the concurrency paradigm? Thread safe or work with processors like Elixir?
That is another area where I think Rust is uniquely strong. The lifetime checker of Rust and its definition of correctness with respect to lifetimes is what Rust uses to express correctness of concurrent programs. Now, I don't mean total correctness. I don't mean that Rust can verify that your that your concurrent program is correct. I mean correct with respect to lifetime and with respect to concurrent access to shared variables. So for example, if you declare a global variable in Rust, then ordinarily that variable cannot be modified. Now that doesn't sound like much of a variable, does it? But that's the default of Rust. And in order to go to a design where you can modify a shared variable, you have to, in Rust, express how it can be shared. So you can share a mutex object which contains a value. I mean, that's just ordinary mutex. That's not rocket science. That's what every framework has had on Earth for a long time. What Rust does with mutexes, though, is fairly interesting. You cannot access a variable that's associated with a mutex without holding the mutex in Rust. And the compiler verifies this at compile time for you. So mutexes and atomic integers and lots of other common types, the compiler understands enough about what you're doing with those types to verify that you're using them correctly. So one problem in C++ development that is a huge problem is reference counting in COM objects. COM objects are reference counted, and you can do reference counting one of two ways. I mean, there's more than two, but let's just focus on these two. One is single-threaded objects where your changes to the reference count are done as ordinary memory accesses. They're not interlocked access. They're not atomic accesses. Those are very efficient for single-threaded code. The other way you can do it is using interlocked access or atomics, whatever you want to call it, which is correct for multi-threaded programs, but you pay a cost. You pay a substantial cost to use atomic accesses. And the problem for C++ developers is they're never quite sure which one to use. They're never quite sure whether they should write their code defensively using the atomic reference counting, and therefore always pay a cost even when they don't need to, when they're running in a single-threaded application, or whether they should make the other error, which is use the more efficient but more dangerous option. What makes Rust so great is it has both of those options. It has an RC type for single-threaded reference counting, and it has an ARC type for atomic reference counting. And you can't use them incorrectly. You can't accidentally use one in a context where you should have used the other. If you're going to share objects across threads, your objects need to implement what's called the send trait. And the send trait is only implemented for the arc type, the atomic reference counting. It's not implemented, very intentionally, for the RC type. I'm sorry, not send, sync. There are two traits that have very similar names. Sorry. Anyway, long story short, a great deal of what Rust does is prevents you from writing basic and even intermediate concurrency bugs. And there's great frameworks out there that allow you to build on top of that safety to build very high performance concurrent applications. So for example, the Rayon crate is one of the best known for taking an algorithm and giving it to a thread scheduler and saying, do a bunch of work for me. I don't care where, I don't care when or how, but just put it on some threads and then give me the result. And you have this very nice interface of parallel iterators. So you give it an iterator of a set of things to do, and then you get, as a result, an iterator that is the result of that computation. And in the middle, there's lots of processors tearing your work items into pieces.
Nice. That answers the question perfectly. Thank you. So a couple questions have come in, and this got a +1. Of wondering if Microsoft is going to provide more contributions to the Rust project or get more involved since some of the core contributors from Firefox have dropped out.
That is a great question. I wish anyone had more real data on that. I know the news for Firefox was very unwelcome. Like, I don't want to see anyone lose their job. I don't want to see any hit to Rust development, and we're still trying to understand what the real impact of that is. We know that the work on creating the Rust Foundation has accelerated. It was something that was kind of slowly lingering in the background, and it's now been pushed to the foreground, and Ryan is by far the better person to talk to about the state and future of the Rust Foundation. I really can't speak to individual developers or what their plans are or how that's going to affect Rust. I think At this point in time in Rust history, we are well beyond a certain critical threshold. I think Rust is self-maintaining by this point. I think the patterns of the language and the patterns of the community and how to evolve this technology over time are well established enough to adapt to this hit, this unwelcome news about Mozilla. So it's a very unfortunate set of events. I don't have clarity on really what's going to happen in the near term about it, but I'm not that worried. I dearly hope that everyone who had a personal hit to their own career is taken care of, that they're able to find good work. And I dearly hope that many of them are able to continue to contribute to Rust, whether for their other companies or for Rust directly. So that's really all the information I have about that.
Gotcha. All right. So moving on, and actually the last question that I have for now, and then we can just take questions from chat for the rest of the time. But this is just about learning resources for Rust. And kind of chatting about any recommendations that you would have. That was a question someone had asked way earlier that I said that we would hold till the end, but especially for those who are brand new to the language, what kind of resources out there do you recommend?
There's two main categories of resources. There's stuff written by humans, and then there's just the body of code out there written in Rust that you can just go read as an example. And I think the Rust language website itself has fairly good documentation. I mean, it's fairly comprehensive for any language, much less a new language. The Rust book, called The Book, is a great place to start. So definitely start there. And then once you're ready to write your first Hello World app, just start writing some code. Just write code, write more code. And then go find Rust code that other people have written. There's a ton of code out there. Just read it, make some small change, run it, see what it does. And that is by far the best way to learn. So many of the ideas that are just strange new things like traits and trait objects and monomorphization and all these crazy things that you'll read about, they will make sense when you begin writing code and doing it incrementally. That, and don't skip the section on the borrow checker.
Okay.
Don't skip the section on the borrow checker. Really read it, like read it as a chapter, read it from start to finish, because nothing after that will make sense unless you've got a fairly good grasp on those ideas.
Gotcha.
What a reference is and what lifetime is, those are the fundamentals in Rust. They're inescapable, and once you understand them, it's not that you want to escape them. They're one of the main ways that you can achieve correctness. They're one of the main ways that you can understand what your code is really doing. So often we as developers write code and we think we know what it does, and it just does something different. And I love Rust because it makes me think about what my code is really doing. I think one of the things that drives people crazy about Rust is their code won't compile until certain bugs are fixed. And no, I'm serious. And that drives us crazy because we want to run the code that we wrote, right? And scripting languages feel so freeing. Like you can write some code and it'll run, and maybe like the first 5 statements work correctly, and then like statement number 6, there was a bug in there, but I got to see what steps 1 through 5 did, and that's great. Rust requires some delayed gratification. You're not going to get to step 6 until all your code in steps 1 through 5 compiles. Not necessarily works correctly, but at least compiles. And so Rust will force you to understand and fix certain bugs before you can run a single line of your code. And that's kind of a cultural shift for some people. I love it. I came from a very strong static type checking background as far as the languages that I grew up with. But I understand why that drives some people a little nuts.
Sure. Yeah. I also come from a background, of testing, and specifically things like TDD, and I feel like that is very important to me. So I think I understand what you're saying, Arlie, about I don't know. I don't mind kind of these obstacles and having bugs before things compile and work. So I was just let me go ahead and share this. I am sharing this. You had mentioned the Rust book. I did drop a link in the Twitch chat about it, but if you just go to rust-lang.org/learn, or just even explore the website, you can find lots of great resources here. Highly recommend the book. Don't skip the chapter on borrow checker. I also highly recommend the Rustlings course. Like Arlie was saying, if you want to get hands-on, this is a really quick way to do that with very short programming exercises where you kind of just fix a problem and get the program to work and can move on. And Rust by example is also another great kind of a book form as well, but you can kind of execute code directly in there. So that is another great resource that I would recommend while you're here. So all three of these, which are on the Rust website, you can find.
Let me add one more thing to that. At the beginning of that set of paragraphs, I said there's kind of two categories of information, the stuff written by humans.
Yep.
There's the other stuff, which is the auto-generated docs from crates. And crates are libraries that people have published in packages. So if you go to any crate and go to its documentation link, you will go to a page that looks very familiar, very similar to that of all the others. And that's because they all use the same doc generator. And because it's so consistent, once you learn how to navigate the docs, you can read up on any crate. So this crate, the RAND crate, is a nearly universally used crate for generating random numbers. The way that these docs look, the standard library looks the same, request looks the same, the HTTP client looks the same, they all look the same, and it is such a relief to see such a huge community that is so consistent in how it organizes information. So that alone has been a huge benefit to me in learning Rust. And when I say learning Rust, I don't just mean the language. I mean Rust, the whole ecosystem of the crates that you can use in Rust.
Right, right. Very helpful. Yeah, I totally recommend the same thing. I think you can start at crates.io, you can start at docs.rs, and kind of just explore from here, search whatever it is that you might be looking for, or just kind of explore around. But I think the docs in Rust are fantastic. I've always found them extremely helpful. So lots of good things to learn there, at least if you want to learn from things humans have wrote, as you said, Arlie. And then I also just give a shout out to the GitHub repository. This is the org for Rust specifically, but there's lots of repositories here. You can check out the Rust repo. If you want to learn more, if you want to learn how to contribute, like take a look around at the issues, see what kind of things are up for grab that you might be able to help out with. That could also be a great way to get some hands-on experience too. All right. Let me go ahead and stop sharing for now, and I'm going to head back to the chat to see what final questions we can take. We just have a couple minutes left. Another recommendation that we got was Rust in Action by Tim McNamara. I'm not familiar with that particularly. Arlie, are you?
I'm not. I'll have to go check that out.
Yeah. Okay, so let's see. How do you start with Rust to enjoy it? Do you build a to-do list, some web API? What would you recommend? Let's see. I think that's a good question, and I think from someone who's newer to Rust, that's something that I've kind of asked myself as well. Like, what do I even want to get started with? What do I build? And I started by just kind of building some like small command line apps, just to get a little bit more familiar with the syntax. And how to write it. I don't know if that answers the question about how do you start to enjoy Rust, but at least that's kind of where I started.
Well, how would I learn Rust in a way that I think is enjoyable is one question or one variant of that question, and that's the one that I'm going to choose to answer.
Sure.
If I were to start this whole process all over again, I think the main thing that I would do is go look up existing projects and grab their code, build them, edit them, run them, add features, change things. I've always found changing an existing thing to be a great way to learn about it, because let's say it's a UI-centric thing, like it's a website or whatever. You run it, you see it, you interact with it, you have a certain mental model of what it does and how it works. And then you go look at the code and you can see the correspondence between your mental model and what it does, and that teaches you. And just changing some text or adding a function or adding a button that does something is a great way to learn. So I've always found that when I open, the new project and see that blank screen of I get the kind of the blank page terror effect. Why would I create a whole new project, right? The main new projects that I love creating are really those that integrate other existing packages. For example, there are Rust bindings for existing programs and libraries that are not written in Rust, but they allow you to access them in Rust, like FFmpeg. If you want to do some audio-video transcoding and you want to write a program in Rust that integrates that with, I don't know, pulling metadata off of GitHub, that's a great environment to do it in. And you don't need to know a huge amount about audio-video transcoding or a huge amount about how GitHub works in order to integrate those two things into something new. So that's always been an appealing way to me to learn languages also, is just write something that glues other things together in an interesting new way that you hadn't thought of before.
Yep, yeah, +1. I think I highly recommend that. Where do you think is the best place to go and find some existing projects, like just searching around GitHub or starting kind of at crates.io, or what route do you recommend?
Those two are one and the same.
Okay.
Nearly all crates that are published on crates.io are backed by repos on GitHub. So the crates.io is a great place to search for like the categories of code, and they're almost always going to lead you to the documentation page, which is auto-generated from source code, or they're going to lead you to a GitHub repo or both. So just searching for things on GitHub in Rust, you're going to find a ton of stuff. And again, one of the huge categories of things is what I was mentioning before is writing bindings that allow you to access other frameworks in Rust. Like earlier, you had one up that was, I think, accessing something about field functions. I have no idea what field functions are, but I know there's Rust bindings for them now. So if I want to do something with field functions, then I can create my new Rust project that accesses those through those bindings. Or writing bindings for a package that you're familiar with. If you've been working on some code that does something cool and interesting, think about how you might write a Rust API that exposes that package to someone else that's writing code in Rust. I think Rust is a really fun language for doing incremental development in because it has such good testing support. To write a test function in Rust, you just write a function and then add the test attribute to it, pop over to the command line and type cargo test, and all your tests get run. It's just super crazy easy, and everyone does it. The Rust code out there in the wild is just filled with test functions, which is another great way to understand what something does, is to read a test function.
Absolutely. Yep. And you should definitely test all your code. So thanks for all those suggestions of kind of where you can go to explore some existing code and projects. I think that is a great start. I hope that definitely answers the question and kind of gives you a place to start. Whoever asked that question, we are over time. So Arlie, I should let you go. But thank you so much for joining me today. Just really appreciated chatting about Rust, learning a little bit more from you. Yeah, I don't think there's anything else unless you have any final words, Arlie.
No, that's it. Thanks for the chance. I always love talking about my favorite language.
Yes. And I hope that this has inspired some of y'all to go and explore Rust. I think we have some kind of or more new Rustaceans here. So hopefully you definitely learned something new. And as I mentioned, this is now our second stream of the week. We'll be back tomorrow for another stream, and you can find all of the recordings either here on Twitch for a couple weeks or also at youtube.com/Microsoft Reactor. So yeah, that is about it. And have a great day, everyone.
Take care.
See you, Arlie.